I have a lot of people asking me the problem, how do I know if it's going to accelerate in the y or not? It seems like a lot of the time acceleration in the y is just assumed to be 0. So how do I know that it's not? So that's what we're going to look at right now. So I've given myself a problem here. We're just going to make it frictionless because we're not really worried about friction right now. So in other words, I put mu as 0 here. That was a terrible underlining job. There we go. That's better-ish. So let's begin with the force diagram. Okay, we're going to have, of course, this force tension right up here at 100 newtons. Okay, so that's force tension, which I've already labeled on there. We're going to have force gravity down, of course, and force normal is going to go up. Now, force normal is not going to be quite as big as gravity because force tension here is helping. Okay, so there we go. And all we're going to look at right now is, does this accelerate in the y? Alright, now the way to figure out this problem is to assume that it doesn't. Now let's begin with actually an easier answer, or an easier situation, in that the force goes down. Okay? Now the only thing countering force gravity, if this force tension had gone down in the y, then you have force gravity pulling down and force tension pulling down. The only way that that accelerates down through the y is if this surface then like breaks, allowing the object to move down. Now, since that's unlikely for these problems, and we haven't really talked about anything, that just assume that the surface will never break, so it's not going to go down in the y. So the only really tricky situation is what if it pulls up? Okay, well, here, let's figure out. So what I usually do in this situation is I will assume that it doesn't, and we'll try to find force normal. Force normal will be our key to figuring out whether or not it accelerates or not in the y. So here we go. Let's sum the forces in the y. And again, we're going to assume that it doesn't accelerate. Okay? And then we sum the forces. Force normal will be positive. We have force tension in the y, which is positive. And we have force gravity, negative, equaling 0. Now, force normal will equal force gravity minus force tension in the y through just some simple algebra of moving those both over to the other side. Force gravity is just going to be mass times g, which is going to be 10 times 9.81 or 98.1 newtons. Force tension in the y is going to be this 100 newtons. And because my 30 degrees is right here, what I want is the opposite. So that's sine of 30 degrees. Now I did this one easy on myself here. Sine of 30 degrees, if you remember from your basic triangles, is just 1/2. So that means that's negative 50 newtons. Meaning that force normal, if I calculate it here, is 48.1 newtons. What does that mean? Well, what that means is that force normal had to add to the 50, or add to that there, in order to counter force gravity. So force normal has to help. What's the only way that force normal can help? Well, if it's on the ground. So we were correct, since we have a force normal here, in assuming that we do not accelerate in the y. Because it's not going to accelerate down, as we previously discussed, and here it's not going to accelerate up. Let's look at a rare case in which this would not be the case. Alright, so our situation used to be 100 newtons. Here we're going to keep almost everything exactly the same, except the only thing that we're going to change now is this is no longer going to be 100 newtons, but instead going to be, let's go with 400 newtons. So we're pulling 4 times as hard as we did just a second ago. Now, again, what you're going to do is you're going to set up the problem, assuming that it's not going to accelerate in the y. Again, we set up the problem the exact same way. Force normal is positive. Force tension in the y is positive. Minus force gravity equals 0 because it's not accelerating in the y. We again solve for force normal, doing the same thing that we did just a second ago. That'll be force gravity minus force tension in the y. Force gravity is going to be mg, or 98.1 newtons. Force tension in the y is going to be that 400 newtons sine of 30 degrees. Now, as we said, that's 1/2, which makes that 200. All right, so here's our issue. Our final answer to this is negative 191.9 newtons. This negative should trigger something in your head, because I already took care of the negative, or the positive or negative right here. So this negative tells me that force normal should go the other direction. But it can't go the other direction. It has to go perpendicular to the surface. What this problem is telling you is, in order to get a 0 acceleration right here, Force normal would actually have to counter force tension, but it doesn't. So if you got that negative force normal here, what that tells you is actually right here, that force tension is bigger than force gravity. Well, if force tension here was bigger than force, so if that line right there is bigger than force gravity, then that can't be there, because that means that's going to accelerate up. So what we would then do is redo this problem knowing that force normal does not exist. Sum the forces in the y. I know there will be acceleration now. And so I sum the forces in the y, and the only forces acting in the y now are force tension in the y positive minus force gravity, and it will accelerate because that one's going to win. I already have these numbers. That's going to be 200 minus 98.1 newtons. Divide by mass, and that's going to tell me how much I accelerate in the y. So in this particular problem, I believe that's going to be 191, which tells me that I'm going to accelerate in the y by 19.1 meters per second. Well, that's a ridiculous number, but that gives you an idea of how you can figure out whether or not it's accelerating in the y or not. Now, chances are good for most of these problems that it won't, but you need to be able to figure out if it does.